this section, we're going to talk about the chain rule. The chain rule is another one of the properties like the product and the quotient rule that deals with more than one function being combined. Given two functions, we'll call it y equaling an f of u and u equaling a g of x, where y can be defined as the composition of the two functions. Then our derivative, y with respect to x, is going to be the derivative of y with respect to u times the derivative of u with respect to x. Now, looking at this, it almost looks like a product rule, but it really is what we consider a general power rule. Another way to think of this is, if I think in terms of the composition here, derivative of y with respect to u is saying I'm looking at an f prime, so the derivative of the f, with respect to u, which is g of x, times the derivative of u with respect to x, which is g prime of x. So this would be our derivative of f with respect to x, given f being a composed function of g. Okay. Looking at this a little closer, another way to think of this is if I have a composition of functions, what I'm going to do to take the derivative is derivate the outside function, leaving the inside alone, and then multiplying by the derivative of the inside. Okay? This again is our chain rule. Again, another function that you will need to know when we get to the final exam. Let's take a couple looks at some examples of the chain rule. Okay, this first example is one where we can definitely think of it as a general power rule. Meaning, if you remember our power rule, it said I'll take the exponent off of my function, move it down to the front, and then take the derivative of the inside while subtracting 1 from the exponent. If I think of it that way, in this case, if I want to find y prime, it says I'm going to leave x cubed plus 2x and think of that as just my variable. And essentially I'm looking at my variable raised to the 7th power. So I know that by the power rule, this is going to be 7 times my variable raised to the 6th power. My variable in this case being x cubed plus 2x. Now again, obviously that's not the entire derivative because I have to take into account the fact that I'm composing with something other than x. And so here I'm going to take and multiply by the derivative of that inside piece. Again, to simplify, which we should always do for our solutions, all I can do, because the power on that first term, is multiply the 7 times that other factor. And there would be my derivative. Okay. In this second example, I can again think of this as a general power rule. So again, I can think of rewriting this function as 2x cubed plus 5x to the 1/2 power. And now I can treat it like a power rule. So just like before, to get my derivative, I can think of bringing the power down front, leaving the inside alone, and subtracting 1 from the exponent. So there's my f prime times g, or f prime of g. Now I need to multiply by g prime of x. So multiply by the derivative of the inside piece, which will be a 6x squared plus 5. Again, I want to simplify this down. In this case, the negative exponent is going to put it in the denominator. So I'll have a 6x squared plus 5 divided by 2 square roots of 2x cubed plus 5x. And there would be my derivative. In this next example, we are looking at a combination of some of our rules. So just like with polynomial functions, when we combine some of our basic properties like the addition and subtraction, the coefficients, and the power rule, we can have functions that combine our product, quotient, and chain rules. Okay. In this example, I am looking at a quotient rule combined with a chain rule. To take my derivative, I first need to determine which rule I'm applying first. Okay? If I look at this function a little closer, I can see that my quotient is inside of my power. So here I want to apply my power rule first and then apply my quotient rule. So in this case, I would take my chain rule, which says I'm going to bring the power down front, subtract 1 from the exponent, and then I'm going to multiply by the derivative of the inside. Okay. In this case, the derivative of the inside is what brings about my quotient rule. Okay. So my derivative here, this first piece is going to be left alone. The second piece, I'm going to apply my quotient rule. So our quotient rule says derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Of course, just like every other function, we need to simplify. Okay? So we'll do this in stages. Again, the first piece I'm going to leave alone because there's not a whole lot I can do to that. At most, I'll be able to distribute the power to both the top and the bottom, but I'm going to have to simplify that bigger piece first. Okay? So here, I want to go ahead and simplify, so I'll distribute those terms through, and then combine like terms. Okay, so there's our distributing. Now we can combine like terms in there, and here I'm going to go ahead and distribute that power to both the top and the bottom. So we've got a 2x plus 5 to the third divided by an x squared plus 1 to the third. I'm going to multiply that, go ahead and combine the terms there. So we're looking at a minus 2x squared minus 10x plus 2 over an x squared plus 1 squared. Now, again, if you can factor these polynomials, go ahead and do so. In this case, that one's not going anywhere. So now we can go ahead and combine things. Notice in the denominator, I accumulate some powers. So we are looking at a negative 8. So I'm going to pull a negative 2 out of the top and multiply it by that 4. We'll get a 2x plus 5 to the third. Pulling the negative 2 out here gives us an x squared plus 5x minus 1. And then on the bottom, the x squared plus 1, I now have 5 of those. There would be my derivative. Okay. So there's an example of a combination of your quotient rule with your chain rule.